Hi everybody. In this video, I'm going to go through how to utilize the formulas that we've learned before and apply them to solve some problems. So you're going to be able to use the formula as it's given. We're also going to be able to kind of manipulate the formulas based on whatever information that is in the problem. Okay, so just take a moment. You could review some of the basics: perimeter area for a square, rectangle, perimeter and area for a triangle, and then of course circumference and area for a circle. So these should be familiar. If not, go ahead and take a moment to refresh your memory when it comes to these. And I'm going to jump right into some examples, and hopefully they'll start to ring a bell once you see them again. So for this first example, they're asking for the perimeter and the area of the basketball court. So the basketball court is in the shape of a rectangle. So we can go ahead and use our formula for rectangle, which for perimeter, we could do it a couple different ways. You could look at this as just adding up all four sides that make up the length around this rectangle. Or if you recognize that in a rectangle, opposite sides have to be the same, we can kind of use that idea to just say, all right, if this one's 84 feet, I could just double that to figure out how long it is on the sides here. And then if the length up here is 50 feet, I could double that to figure out how long it is for those two sides and then put those together. So you kind of have options of how you want to approach it. And I'll show you that it's really the same both ways. So let's say you just go ahead and you labeled all your sides so you knew what each side was individually. And then you just decided to add them all up. So I could totally see somebody saying, all right, I'm just going to add up 84 plus 50 plus 84 plus 50. And let's see, that's 268 feet, it looks like. If you add those all up, you can grab a calculator if you want. And that's going to be our total perimeter around the basketball court. But you could also have done it by, again, realizing that you're basically doing two of these and two of these because it's a rectangle, right? Opposite sides have to be the same. So I totally could see somebody setting it up this way instead, in which case then you'd get 168 plus 100 is 268. I could even see somebody doing it this way, saying, you know what? I know that if I just add those two sides together and then double that, I'll get the total. So what I mean is, if you're basically doubling the 84 plus the 50 together, you should get the same thing. This is going to be 2 times 134, which is 268. So as far as what method you choose, it doesn't really matter because you're going to get the same thing with each method. You kind of just have to pick the one that makes the most sense to you when you're doing it. And in the end, you want to be as efficient as you can. But as long as you're doing it correctly and you're getting the right answer with the right work to justify it, it doesn't really make a difference. And that's the perimeter. For area, there's probably only one reasonable way to go about doing that one, and that's simply using the base times height idea. Okay, so it's going to be base times height. In this case, the base is 50 times 84. Okay, so this is going to be, oh boy, so let's grab the calculator just to be sure. I don't want to mess up on my units here. So I'm going to do 84 times 50, and I get 4,200. So 4,200, and the units are going to be square feet, right? Because this is 50 feet times 84 feet. In fact, you can put that on here if you want to kind of help you remember, right? And then feet times feet is square feet. So the perimeter was 268 feet. The area was 4,200 square feet. And I think we've gone ahead and solved that problem. All right, hopefully that made sense. Let's go ahead and try another example. This time it looks like they're giving us a circular patch. So they're asking us to find the circumference and the area of the patch. So some kind of soccer patch here. And they give us this length here is 9 centimeters. All right, so we got to kind of understand what that 9 centimeters is representing. It's the distance from essentially here to here, right? That's 9 centimeters. Well, that's the diameter. So they're actually giving us the diameter of the circle is 9 centimeters. And when we go to do our circumference and area, if you recall, formula for circumference and area for a circle, we really want to know what the radius is, right? each of the formulas involves the radius. So we're going to need to figure out the radius based on that diameter. And hopefully you remember the radius is going to be half of the diameter. So it's 4.5 centimeters. So the distance from here to here is 4.5 centimeters. And that's your radius. Okay, that's R. So circumference is 2 pi r. For pi, we typically use 3.14. So when I go to put this in the calculator, it's going to be an approximation. 2 times 3.14 times the radius, which is 4.5. And I'm going to go ahead and figure that out and see what our circumference actually is. So 2 times 3.14 times 4.5. So I got 28.26. And that's going to be centimeters because they gave it to me in centimeters. That's the circumference. Now, some people might say, Mr. Miller, what if I want to use the pi button, right? Maybe you got a fancy calculator, maybe your phone will allow you to do it. And instead of doing 2 times 3.14, maybe you did 2 times pi times 4.5. And look what we get when we do that. We get 28.27 and some other decimals going on here past the hundreds here. But that's still pretty close to what we got. And for all intent and purposes, the 28.26 is good enough. In fact, a lot of times they actually even have you rounded to the nearest tenth. So 28.3 would be fine. And this would have been 28.3. So this is not wrong. In fact, this is more accurate. But sometimes they're okay with just using 3.14. So make sure you read the directions if it asks specifically. Otherwise, just take your pick, and as long as the work is there, you'll be okay. I'm just worried if it's a multiple choice and you do one method versus the other, you might think you did it wrong, when in fact you didn't do it wrong. You just either used a more accurate answer than what they did, or maybe a less accurate answer, which might have been what they were looking for. So you kind of have to just read the directions and see what it says. So that takes care of the perimeter, or circumference really, same idea. And now we can go ahead and do the area. Area of a circle is pi times the radius squared. And in this case, I'm going to use 3.14 again. The radius is 4.5, and that's squared. So I'll let the calculator help me with this one. So 3.14 times 4.5 squared. Nice and convenient way to do it on here. If you need to use parentheses, if you're doing it on your phone and it doesn't have the capability of doing the squared like this, I'll clear that for a second. You could do this 3.14 times 4.5 times 4.5, right? That's the same thing as 4.5 squared. Either way, we're going to get the same thing, and we should get about 63.585. 63.585, and that's going to be centimeters squared because we're squaring the centimeters for the radius here. Pi times that gets us about 63.585, or 63.6 if you want to round to the nearest 10. The directions here, it doesn't look like it actually told us. It just said find the approximate area. So I think showing the work that I showed and then rounding it the way I did is totally sufficient for this problem. Okay, that takes care of the circular example. Let's try one that looks a little different. This one's a little bit maybe SAT type or IXL type, or some other kind of standardized thing that you might be doing. So it's a good practice. They're giving us the coordinates of the triangle here, okay? And they're asking us to find the approximate perimeter of the triangle. So perimeter, of course, we need to figure out how far it is around the object. So I need to know how far it is here. I need to know how far it is here and how far it is here. Well, from Q to S for this part isn't too bad because it's just a horizontal segment. We can just figure out how far it is to go from 1, 2 to 5, 2, right? We're going from 1 here to 5. How many units is that? 1, 2, 3, 4 units, right? 5 minus 1 is 4. So I already know one of them, QS, is 4 units. And that takes care of one of the sides. But I still need to figure out this one, and I still need to figure out that one. And there's only one way we've learned to be able to do that. We're going to have to use the distance formula for this. So perimeter means find the length around, the object. So, the length around the triangle here. So we need to figure out the length of QR. So QR is going to be the square root x2 minus x1 squared plus y2 minus y1 squared. And if you need a refresher on distance formula, those videos are available as well. But I'm just going to jump right into it here. This is what we need to solve this problem. So this becomes 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. So that becomes the square root of 25. Well, the square root of 25 is actually 5. So now QR is 5 units. So this is 5. This was 4. If I can just get from R to S, I think we can figure out our perimeter. So from R to S, I'm going to do the distance formula again. 4 minus 5 squared plus 6 minus 2 squared. So this becomes negative 1 squared plus 4 squared. Negative 1 squared is 1. 4 squared is 16. I get the square root of 17. And they did say, I'm looking at all the choices here. It does say approximate, and it's also rounded to the nearest tenth. So I'm going to have to round this to the nearest tenth. According to the calculator, the square root of 17 should be a little over 4, right? Square root of 16 is 4. So square root of 17 is 4.1. 4.1 units. So I have all three sides now. 4.1, 4, and 5. The perimeter then is going to be the length of all three together. 5 plus 4 is 9, plus 4.1 is 13.1. Looks like the answer is C. 5 plus 4 plus 4.1. And that gives us the 13.1. And there's your perimeter for that triangle. So this one's a little tricky because they didn't really give you any lengths. You had to make the connection of converting the idea of perimeter to figuring out each length individually. And to figure out each length individually, we had to use what we knew about coordinates and distance. All right, let's go ahead and solve A here and see how we did. They're giving you the base of a triangle is 28 meters. They're giving you the area is 308 meters, right? So those are given. Those are given. And they're asking us to find the height. So basically the height is the unknown. So if I draw it in my picture here, this height is unknown. Now you may not have drawn it that way. Maybe you drew it this way. Maybe you drew it as a right triangle and you put 28 meters here and you mark this as the height. That's okay. It doesn't make a difference because based on the information that's given, that's really all that's locked in. The actual shape, or orientation, I should say, of the triangle itself isn't really that important. So in both cases, we do know how to find area of a triangle, hopefully. Area of a triangle is 1/2 the base times the height. And the reason why this is sort of a good one to practice is because they're not giving us the base and the height and saying find area. They're actually giving us the area and the base and saying find height. The good news is the formula doesn't change, so we can keep using the same formula. It's just a matter of manipulating it in a way that makes it easier to solve. So I'm going to go ahead. I think the best strategy is just substitute in right off the bat. Get some numbers in here. The sooner you get the numbers in, the more comfortable you're going to feel. So if I put the 308 in for area, and then I put in the 28 for the base, now I have an equation with one variable. Could we solve this equation for h before we substitute? Absolutely. I'll show you that method as well. But for this first go around, I think it probably gives you a little more comfort to see the numbers in the formula and then start simplifying. So 308 equals half of 28 is 14 times h. Divide both sides by 14. So h is, looks like 22 meters. We can check it, right? We can check it in our calculator. If the height is 22 and the base is 28, so 1/2 times the base times the height. We should get 308 if we did this right. 308. So now we know we did it right. Another method you could do to manipulate this equation, like I was saying before, is let's start with, forget B for a second. Let's start with this formula one more time. Area is 1/2 base times height. And let's pretend we don't know the numbers yet. We can solve this for h and have an equation that's h equals instead of a equals. First thing we're going to want to do is deal with the 1/2. Well, to get the 1/2 over to the other side, I can multiply both sides by 2. Right? 2 times 1/2 is just 1. Sometimes you learn this as multiplying by the reciprocal. So really, we're multiplying by 2 over 1. Sometimes you can think of it as just dividing by a half, right? If you divide by a half, that's the same as multiplying by 2. So it kind of just depends on how you learned it and how you remember it. But in the end, in order to get this over to the other side, I'm essentially multiplying by 2. So 2a equals b times h. And now we can divide both sides by b. Divide both sides by b. So then h is 2a divided by b. Let's check it out with the one we just did. The height is what we're looking for. The area is 308, and the base is 28. Well, 2 times 308 is 616 divided by 28. 616 divided by 28 is 22. Same thing, 22. So I got a little scrunch there for room. 22, I'll put it over here. H equals 22. So 2 different methods for solving the same problem, and both ways work, of course, and both ways have their value. I think when you have numbers, sometimes it's easier to just get the numbers in. If you don't have numbers, this is the way you would manipulate it, and it's essentially doing the same algebraic steps that we did, up here. The only difference was I simplified the 1/2 first before I brought the 14 over. But we still got the same thing for both, 22 meters, and that problem is now solved. All right, hopefully now you're ready to solve B. Example B here. So this time we have a rectangle. We have a rectangle that's width is 17 inches. So 17 inches. The perimeter is 102 inches. And they're asking you to find the length of the rectangle here. Okay. Now it doesn't really matter which way you orient it. Some people do put the width here and then the length here, but I can make the rectangle this way and it'd be the same dimensions, right? So 17 inches is one of them. Length is the other. That's the unknown. And we know the perimeter is 102. Now, remembering what we did on that first example, we know that the length here is going to be the same from this side to this side since it's a rectangle. Similarly, the 17 inches is going to be the same for those two lengths. So when we go to do perimeter, you can think of it as just adding up all the sides, setting it equal to this perimeter, and then solving for the side we don't know. Again, you're sort of working a little bit backwards here since we already know the actual perimeter. Or you can keep it in generic form, 2 times the length plus 2 times the width, and then just substitute in perimeter, width, and then solve for the length. So again, it kind of depends on what your comfort level is with the formulas, but it would be helpful to be able to kind of do it both ways. So I'll do it both ways just to show it, and you can kind of pick whichever method works best for you. So perimeter here is, what do we say, 102, is 2 times L, which I don't know, plus 2 times W, which I do know. So this is 102 equals 2L plus 34. So 2L equals, if I subtract 34, it looks like I get 68. And if I divide both sides by 2, just so happens I get 34. So the length is 34 inches, 34 inches. And you could check it by just adding up all the sides, right? 34 plus 17 is 51, plus another 51 is 102, so it did work. That method is a really good, nice, efficient method. Once you know some values, you can plug it in. But we could also try the other technique of, let's pretend we don't know any of the letters yet, any of the values yet. We know that we're trying to solve for L. So subtract 2W from both sides, right? Subtract 2W from both sides. That'll bring this over here. And then divide both sides by 2. This is going to be L equals P minus 2W all over 2. So that formula is already solved for L now. So once you substitute in your P and your W, we're going to be able to figure out L by just simplifying this part of the equation. So if I have L equals perimeter is 102 minus 2 times W, and W we said was 17, all divided by 2, we should, running out of room here, we should get the same thing. 102 minus 34 all over 2. 102 minus 34 is 68, divided by 2 is 34. Same thing. Same thing. You may look at that and say, you know what, this way looks easier. That's fine. Some of you may look at it and say, you know what, I'd rather solve for the variable first. Either way, they're both good techniques, they're both good strategies, and depending on the scenario, we'll kind of determine which method might be easiest. All right, but in the end, you just need to be able to justify what you're doing and hopefully show the work that led to your solution. All right, your homework is listed here. It's from the textbook. Please go ahead and give that a shot. And if you need any help, be sure and let me know. Have a good one.